Hello everyone. In this video, we are going to discuss about domain and range of trigonometric functions from the chapter 3 trigonometric functions class 11 max. You see, the trigonometric functions sine and cosine are defined for all real numbers. For each real number x is a real number. For each real number x, minus 1 less than or equal to sin x less than or equal to 1 and minus 1 less than or equal to cos x less than or equal to 1. That is, the value of sin x is between minus 1 and plus 1 including minus 1 and plus 1. Similarly, the values of cos x will be between minus 1 and plus 1 including minus 1 and plus 1. Now, consider the function, trigonometric function y is equal to sin x. Now, you see, the domain of this function sin x, domain of sin x means the values of x. That is actually the set of all real numbers. So, domain of this function y is equal to sin x is set of all real numbers. Okay, and you see, what about the range of this function y is equal to sin x? You see, range of the function sin x means the values of sin x, that is the value of y, that is actually the range. Okay, so here you see value of y, which is actually the value of sin x, that is actually the range. So you see values of sin x actually changes between minus 1 and plus 1 including minus 1 and plus 1. That is, the range of this function sin x is actually the closed interval minus 1 comma 1. That is, it has values minus 1 and values between minus 1 and 1 including minus 1 and 1. Okay, that is, we can write minus 1 less than or equal to sin x less than or equal to 1, or we can write minus 1 less than or equal to sin x is actually equal to y, so less than or equal to plus 1. Now, let us consider the other trigonometric function cos x. That is, we are taking y is equal to cos x. The domain of this function cos x means the values of x. Values of x is actually the set of all real numbers. So, domain of this function y is equal to cos x is the set of all real numbers. And range of this function, range means values of cos x, that is value of y. See, values of cos x is actually between minus 1 and plus 1 including minus 1 and plus 1. So, the range will be the closed interval minus 1 comma 1. That is minus 1 less than or equal to cos x less than or equal to 1. Or you can write it as minus 1 less than or equal to cos x is actually what? Y. So, less than or equal to 1. So, this is actually the domain and range of this function cos x. Now, let us consider the other trigonometric function which is y is equal to cosec x. See, we know that cosec x is actually the reciprocal of sin x, that is 1 by sin x. Then domain of this function y is equal to cosec x is actually the set of all x such that x belongs to the real number set and x not equal to n pi, where n belongs to the integer set of all integers. That is, the domain of this trigonometric function y is equal to cosec x is a set of all real numbers, but this real number x should not be equal to n pi. Because when x is equal to n pi, here sin n pi that becomes 0, 1 by 0 is not defined. Okay, similarly, the range of this function y is equal to cosec x is actually the set of all y such that y belongs to the real number set and y can be greater than or equal to 1 or can be less than or equal to 1. That is, the range y should not have the value 0. So, cosec x can have values greater than or equal to 1 or less than or equal to 1. It cannot have value 0. Now, let us consider the other trigonometric function y is equal to sec x. Sec x is actually the reciprocal of cos x, so 1 by cos x. You see, the domain of this function sec x is actually the set of all values of x such that x belongs to the real number set and x not equal to 2n plus 1 into pi by 2, where n belongs to the set of integers. See, here x should not be equal to 2n plus 1 into pi by 2, because when x is 2n plus 1 into pi by 2, cos of 2n plus 1 into pi by 2 is actually 0. So, denominator becomes 0. So, this will be 1 by 0, which is not defined. Okay, now range of this function sec x is actually the set of all y such that y belongs to the real number set and y can be less than or equal to minus 1 or y can be greater than or equal to 1. Now if you consider the other trigonometric function y is equal to tan x is actually sin x by cos x. So the domain of this function, that is the values of x, set of x, this is actually the set of all x such that x belongs to the real number set and x should not be equal to 2n plus 1 into pi by 2 where n belongs to the set of integers. Because you see, when x is equal to 2n plus 1 into pi by 2, this cos value, cos of 2n plus 1 into pi by 2 becomes 0. So this is like sin x by sin of this value divided by 0. So any value divided by 0 that is not defined, no, that is why we are saying that, or that should be taken as infinity. So that is why we are saying that this should not be equal to 2n plus 1 into pi by 2. Then range is actually the set of all real numbers. Range of y is equal to tan x function is set of all real numbers. Now if you consider the other trigonometric function y is equal to cot x. Cot x means actually cos x by sin x, or it is the reciprocal of tan x. So domain of this function y is equal to cot x is actually the set of all x such that x belongs to the real number set and x not equal to n pi, where n belongs to the set of integers. See, when x is equal to n pi, what happens is sin n pi becomes 0. So denominator becomes 0. This will become infinity or not defined. That is why we are defining it like this. Now range of y is equal to cot x function is the set of all real numbers. Now you see, when we have discussed about the sign of trigonometric functions, we have seen that in the first quadrant, all trigonometric functions are positive. In the second quadrant, sine and its co-function, which is cosec, are positive. All other trigonometric functions are negative in the second quadrant. In the third quadrant, tan and cot x are positive. All other trigonometric functions are negative. In the fourth quadrant, cos x and sec x, they are positive and all other trigonometric functions will have negative values. So anyway, you see, let us consider the function y is equal to sin x here. We are considering this function y is equal to sin x here. So in the first quadrant the angle, see, I am measuring this angle from this axis and in general I am taking that angle as x. So here you see the angle x increases from 0 to the maximum value in the first quadrant is pi by 2. So in the first quadrant, as the angle increases, x increases from 0 to pi by 2, see, the value of sin x will increase from 0 to 1. As the value of x, angle x increases from 0 to pi by 2 in the first quadrant, the value of sin x, that also increases from 0 to 1. Okay, now in the second quadrant, the angle increases from pi by 2 to pi. Okay, see here this total angle is pi. So here the angle increases from pi by 2 to pi. So as the angle x increases from pi by 2 to pi, the value of sin x actually decreases. When you substitute the values here, you will get this result. So value of sin x decreases from 1 to 0. Similarly, in the third quadrant, the angle increases from pi to 3 pi by 2, 270 degree. Then value of sin x will decrease from 0 to minus 1. And in the fourth quadrant, the angle x increases from 3 pi by 2 to 2 pi. That is, we get one complete revolution. So we will come back to the same point. So total angle will be 2 pi radian or 360 degree. So in the fourth quadrant, value of x, the angle x increases from 3 pi by 2 to 2 pi, and the value of sin x will increase from minus 1 to 0. So we have just discussed about the behavior of the trigonometric function sin x. Similarly, the behavior of the other trigonometric functions cos x, tan x, cot x, sec x, cosec x, everything is given in this table. So here you see in the first quadrant, sin value increases from 0 to 1. In the second quadrant, it decreases from 1 to 0. In the third quadrant, sin value decreases from 0 to minus 1. And in the fourth quadrant, sin value increases from minus 1 to 0. Similarly, when you consider this tan function, the value of tan function increases from 0 to infinity in the first quadrant, increases from minus infinity to 0 in the second quadrant, increases from 0 to infinity in the third quadrant, increases from minus infinity to 0 in the fourth quadrant. Similarly, all other behavior are given here. For example, cosec x, its value in the first quadrant decreases from infinity to 1. Similarly, in the third quadrant, its value increases from minus infinity to minus 1. In the fourth quadrant, the cosec value decreases from minus 1 to minus infinity. So, the behavior of the trigonometry functions are actually given in this table, which is there in your textbook. So, here you see we have discussed about this table now. See, here you see we have a tan function here, and in the first quadrant the value of tan x increases from 0 to infinity. Okay, see, in the first quadrant the behavior of tan x is in such a way that the value of tan x increases from 0 to infinity. So in the first quadrant means 0 less than x less than pi by 2. That is the angle from 0 to pi by 2. The value of tan x actually increases from 0 to infinity. That is actually given as the behavior of tan function in the table. So let us just check that. See, we have tan x is equal to sin x by cos x. Okay, tan x is actually equal to sin x by cos x. Now, when x is equal to 0, what about the value of tan x? That will be sin 0 by tan 0, that is sin 0 by cos 0. Okay, tan x will be what? Tan 0 because x is 0. Tan 0 means sin 0 by cos 0. Okay, sin 0 0, cos 0 1, 0 by 1 is 0. That is when x is equal to 0, tan value is 0. Tan x is 0. Okay, similarly when x is equal to pi by 6, tan x will have value tan pi by 6. Tan pi by 6 is actually sin pi by 6 by cos pi by 6. When you substitute the values, you will get it as 1 by root 3. Okay, when x is equal to pi by 4, you will get the tan value as 1. Okay, because sin pi by 4 by cos pi by 4, 1 by root 2 by 1 by root 2, 1. Then when x is equal to pi by 3, the value of tan x will be root 3, which is almost 1.732 something. Okay, similarly when x is equal to pi by 2, the value of tan x, that will be what? Sin x by cos x. So sin pi by 2 by cos pi by 2. Sin pi by 2, that is sin 90 1, cos pi by 2, cos 90 0. 1 by 0 is not defined, or we can take it as infinity. Okay, that is in the first quadrant, that is 0 less than x less than pi by 2, the value of tan x increases from 0 to infinity. Okay, that is tan x gets arbitrarily large positive values of x, large positive values as the angle x approaches to pi by 2. Okay, tan x gets arbitrarily large positive values as the angle x approaches to pi by 2. Similarly, you see in the fourth quadrant, that is 3 pi by 2 less than x less than 2 pi. Okay, the value of cosec x decreases from minus 1 to minus infinity. This actually means that cosec x assumes arbitrarily large negative values, that is minus infinity, so it assumes arbitrarily large negative values of, negative values as the angle x approaches, to 2 pi, that is 360 degree. And you see, the values of sin x and cos x repeats after an interval of 2 pi. That is, sin of 2 pi plus x will be equal to sin x, and cos of 2 pi plus x will be equal to cos x. That means the values of sin x and cos x that repeats after an interval of 2 pi. So cos of 2 pi plus x will be equal to cos x, and sin of 2 pi plus x will be equal to sin x. And you see, we know that cosec x, it is actually the reciprocal of sin x, and sec x, it is actually the reciprocal of cos x. So the values of cosec x and sec x, it also repeat after an interval of 2 pi. Okay, so the values of sin x and cos x repeats after an interval of 2 pi. Similarly, the values of cosec x and sec x also repeat after an interval of 2 pi because cosec x and sec x are the reciprocals of sin x and cos x respectively. And you see, tan of pi plus x is equal to tan x. Tan of pi plus x is equal to tan x. Pi radian or 180 degree. Tan of pi plus x is equal to tan x. That is, the values of tan x will repeat after an interval of pi. Okay, and you see, what is cot x? Cot x is actually the reciprocal of tan x. So, the values of cot x also will repeat after an interval of pi. Okay, values of tan x will repeat after an interval of pi. Cot x is the reciprocal of tan x. So, the values of cot x will also repeat after an interval of pi. And you see, the graph of sin x is actually shown here. This is how the graph of sin x function look like. You see, here we have the x values. Here we have y. Y means y is equal to sin x. And you see, here sin x is having a value 0. Okay, then corresponding to pi by 2 angle, we are having the value maximum value plus 1. Then pi value 0. Then here we have a value which is equal to minus 1. Again at 2 pi we have the value of sin x as 0. That means the value of sin x varies from minus 1 to plus 1. Okay, minus 1, plus 1, 0. Okay, so all other values will be in between these minus 1 and plus 1. And you see, note this point. Here when x is equal to 0, sin x will become sin 0 is 0. That is why at this particular point we are having the sin value as 0. Okay, this will be different for the cosine function. Here you see, as we said, sine function, actually sin x, the values of sin x will repeat after an interval of 2 pi. So here you see, from here to here, 2 pi, 0 to 2 pi, the same shape of the graph repeats after that 2 pi. Okay, similarly here also 0 to minus 2 pi, the same graph repeats after this minus 2 pi to this side. So, the values of sin x will repeat after an interval of 2 pi. And you see, this is the graph for a cosine function, y is equal to cos x. So, here also you see, here you have the value of cos function as 0. Here you have plus 1, again 0, minus 1, plus 1. So, here also the values of cosine function also, varies between minus 1 and plus 1. And you see, at this particular point, that is corresponding to x is equal to 0, cos x will be what? Cos 0. Cos 0 is actually 1. So, that is why you see, in the case of sine function, the graph was going through this particular point. But for the cosine function, it starts from this particular point or goes through this particular point, not through 0. Okay, because cos 0 is 1. Okay, so this is the graph, the shape of the graph for a cosine function, and there is a slight difference between the sine function and cosine function. Okay. Here also you see, the shape of the graph actually repeat after an interval of 2 pi. Because you see, corresponding to 0, we are starting from here and this is 2 pi. So, when you consider this particular portion of the graph, again after that 2 pi, you are getting the same shape of the graph. So, the values of cos x will repeat after an interval of 2 pi. Now, you see, this is the graph of y is equal to tan x, that is the trigonometric function tan x. Here you see, this is the nature of the graph for a tan x function. And here you see, we said that the values of tan x will repeat after an interval of pi. So, here you see, see here, corresponding to 0, I am taking this particular graph, then 0 to, between 0 and pi by 2, we are having this particular nature of the graph. Okay, then pi by 2 plus pi, that is 3 pi by 2. So, between pi by 2 and 3 pi by 2, we are having the same shape of the graph. Okay, so the values of tan x will repeat after an interval of pi. And you see, this is the nature of the graph for the trigonometric function cot x. And since cot x is the reciprocal of tan x, the values of cot x also will repeat after an interval of pi. So here you see, corresponding to this pi by 2, we are having that is between 0 and pi by 2. I mean between 0 and pi, we are having this particular graph. Corresponding to pi by 2, we are having this particular graph. Then pi by 2 plus pi, which is 3 pi by 2. So at that particular point also, we are having the same particular shape of the graph. So values of cot x will repeat after an interval of pi. Now you see, this is the graph of the trigonometric function sec x. Okay, this is the graph of the trigonometric function sec x. And sec x is actually the reciprocal of cos x. So the values of sec x also will repeat after an interval of 2 pi. Okay. And you see, this is the nature of the graph for the trigonometric function y is equal to cosec x. See, cosec x is actually the reciprocal of sin x. So the values of cosec x also will repeat after an interval of 2 pi, because values of sin x will repeat after an interval of 2 pi. No? So cosec x also will be like that. So in this video, we have actually discussed about the domain and range of the trigonometric functions, and we have discussed about the graph of sine function, cosine function, then tan, cot, sec and cosec functions. I hope it is clear to you. Thank you.